We're talking about congruent triangles today. And just as a quick review on the word congruent, if two geometric figures have exactly the same shape and size, then they are congruent. So with congruent polygons, two polygons are congruent if and only if their corresponding angles and corresponding sides are congruent. So looking at these two polygons, which also happen to be triangles, they are congruent, so we're going to list out the corresponding angles for that. Those would be angles that are congruent to one another. So I've got angle B from the first triangle is congruent to angle J from the second triangle. I've also got angle A from the first triangle. It's got the two arcs on it, so that would be corresponding to congruent to angle H from the second triangle. And in the first triangle, angle C is going to be congruent to, let's see, it has three arcs on it, so that would be congruent to angle K in the second triangle, which also has three arcs. For the corresponding sides, again, they have to be congruent sides, but this time we need to be a little bit more careful when we list them. So let's talk about that. So my corresponding sides would be this one over here with one tick would correspond to this one over here with one tick. So I'm going to write this one down first. I'm going to call this line segment BA. Now that is congruent to line segment HJ or line segment JH. I could list it either way, technically speaking. But when we're talking about corresponding sides of polygons, we need to make sure that we list them in a way that they correspond exactly with the side in the other polygon. So let's go back and look at this one. BA, I wrote like this, and that was going from the angle with one arc to the angle with two arcs. So when I list the other one, the side with one tick, I want to go from the angle with one arc to the angle with two arcs. So I would say that this is corresponding to line segment JH. For my other two corresponding sides, I'm going to go with the two tick marks over here. So that would be this side. I'm going to go ahead and write that down as BC. And I'm going to look for the side with two tick marks on the other one. So this one has two tick marks. So let's see, BC goes from one arc to three arcs. So when I list this one over here, I would need to go from one arc to three arcs. So I would say that that's corresponding to JK. And then we've got one more pair of corresponding sides here. So in my first triangle, I'm going to call it AC. That's the side with three tick marks on it. So it would correspond to this side over here with three tick marks. But AC goes from two arcs to three arcs. So when I list this one over here, I would need to go from two arcs to three arcs. So I would call this HK. All right, now for the congruent statement. To write a congruent statement, I'm going to state that I'm talking about congruent triangles. The symbol that we use for a triangle is just drawing a little triangle before it. And then we name the triangle using the vertices. So this first triangle, I'm just going to call it ABC. Triangle ABC. And when I say that that's congruent to another triangle, I need to make sure that I list this other triangle also in the same order for the pieces that are congruent from the first one. So angle A has two arcs on it. So the first vertex from the other one that I need to list would be H, the one with two ticks. Angle B has one arc on it. I didn't mean ticks, I meant arcs. Angle B has one arc, so the corresponding angle was J, so I would say J is next. And then angle C, which is the third one I listed, has three arcs on it, so in my other triangle that would be K, so I'd have HJK. Now there are different ways to write this congruent statement for these two triangles. Any combination of ABC that I can come up with, I could write a congruent statement for that. I would just have to make sure that the corresponding angles still matched up. That's all that matters. So if you do write a congruent statement for two triangles and you don't have these corresponding angles matched up, that would be what we would call an invalid congruent statement. Even though the two triangles themselves are congruent, the two statements don't match up if the vertices are not in the right order. So we have an alternate valid congruent statement here on the left, and we have an invalid statement here on the right. I'm going to let you examine that one by yourself. Okay, on the next page there we have some practice problems. So if you feel like you're understanding what's going on here, this would be a great place to pause and try to write down the corresponding angles and the corresponding sides for these two figures here. Okay, so for this one, matching up the angles was pretty easy. Angle P and angle G, angle Q and angle F, angle R and angle E, and angle S and angle D. That was fairly simple, but the sides ended up with a little bit of a kink. These two quadrilaterals actually have two sides, two pairs of sides each that are congruent. So each of them would be isosceles. So that makes writing a congruent statement a little bit trickier, and also the corresponding sides. So PQ and GF, SP and DG, SR and DE, QR and FE, matching them up, making sure you go from the correct angle to the correct angle. So P and G have to match up, and Q and F have to match up every time you do it. So Q and F over here. All right, so when we write the congruent statement this time, we can't write a triangle because these aren't triangles. We would have to say quadrilateral, and typically they just write quadrilateral, QUAD. And then we would need to write a statement for this one. So I think I'm just going to do this one where I go PQRS. So I'm going in order from one arc to two arcs to three arcs to four arcs on the angles. So I'll do the same with the other one. So I'm going to start with G, one arc, two arcs is F, three arcs is E, and four arcs is D. All right, there's another guided practice problem on here. So you should go ahead and try this one also. This one has triangles, but this time instead of giving you tick marks and arcs, they've written numbers. All right, so your congruent and corresponding angles would be J and P, K and M, and L and Q. The sides would be JK to PM, KL to MQ, and LJ to QP. And so one congruent statement would be triangle JKL is congruent to triangle PMQ. And there are several other ways that we could write that congruent statement, as long as J matches up with P, K matches up with M, and L matches up with Q in position. Alrighty, a little bit more. In the congruent polygon definition, the phrase if and only if makes it a biconditional statement. So that means both the conditional and its converse are true. So if two polygons are congruent, then their corresponding parts are also congruent. So that means that we can kind of use this backwards as well. So if they tell me that I've got two congruent polygons, then I can use that to find the missing pieces of a second one. So back to at the very beginning, it said CPCTC, and that actually stands for corresponding parts of congruent triangles are congruent. So this is just a lot shorter. All right, so we're going to do an example here where we're practicing that. They tell me a congruent statement here. They're saying A, B, C is congruent to D, F, E. So this time the two triangles are actually lined up very nicely, so it's easy to tell which sides are congruent and which angles are congruent. They're in the same position. That's actually a nice strategy as well, too. So if you're trying to figure this out, taking one of the figures and redrawing it in the same orientation as the other one helps a lot. All right, so here we go. We're going to find the values of x and y in this one. So let's see. They tell me that x is in this part, but this also has a y. And they give me a y in this part, and the other triangle has nothing but numbers. So that's pretty helpful. Since the side length over here has both an x and a y in it, I can't find that one just yet. I'm going to go ahead and use this one up here that has only one variable and find that answer first. So I've got 8y minus 5 is equal to, this is the angle measure F, which corresponds to the angle measure B. So that would equal 99. So to solve, I would add 5 to both sides. So 99 plus 5 is 104. And then I would just have to divide both sides by 8 in order to get my y value. So let's see, it goes into 10 once. There we go. So y would be 13. And so now I can use that information to find my x. I'm going to start off just writing the statement here. So 2y plus x is equal to, this is going to be equal to the corresponding side on the other triangle. So 38.4. Now I'm going to substitute in the 13 that I found. So 2 times 13 plus x equals 38.4. 2 times 13 is 26. That was using substitution property there. And then I would use subtraction property of equality, subtracting 26 from both sides. I'll get x is 12.4.